So, hello everyone. So, in last class we have discussed the different modules of Kawabata evaluation system for fabrics KESF. So, module 1 which actually measures the tensile and shear related characteristics, module 2 it is bending related characteristics, module 3 it is compressional related characteristics, and module 4 surface friction and roughness related characteristics. And also we have mentioned that ultimately we get a large number of different types of parameters, around 16 parameters we get. And now what do you do with this parameter? So, actually Kawabata system it provides one mechanism to get ultimately overall fabric handle value using all these parameters. Now, this is the equation which we have mentioned, that y is a parameters which we try to get the handle related aspects or tactile which affects the tactile sensations, and C0 is the coefficient of the equation, and C1 is the Ci is the contribution ratio of a particular parameter which is used. So, Xi are denotes the different parameters like tensile related parameters, shear related parameters. So, these are the parameter individual parameters, and m is the mean of this parameter Xi, and this is the standard deviation of Xi. Okay. So, using this, and all the parameters may not be significant for a particular handle response, the tactile response. Okay. So, these parameters are their equations and their weightage is different. Okay. Contribution ratio is different for a particular. Now, let us see an example of this is mechanical. Now, let us see example of 3 parameters. Okay. Cauchy, Shina-Yakasha and Shari. Okay. Cauchy, as we have seen earlier, it reflects the stiffness related characteristics. Shina-Yakasha is flexibility with softness related characteristics, and Shari is crispness. Okay. So, contribution ratio of mechanical parameters C to Cauchy, Shina-Yakasha and Shari using this earlier equation, which is we have that can you can always immediately get, like Cauchy. What is Cauchy? Cauchy means it is a stiffness characteristics. So, here it has been observed that 4 parameters, the 4 parameters are important parameters which are significantly affect. Okay. Now, here we can see the parameters with the positive sign and negative sign. Positive sign means it is actually its increasing direction. If it increases, this will increase. That here if we see for measuring Cauchy, which is it's not the exactly stiffness. In last talk we have discussed, last class we have discussed, it is not exactly stiffness, it is related to the stiffness, and Cauchy its contribution is 37%, maximum contribution, that too it is in positive direction. That means what is Cauchy? B is the bending rigidity. Bending rigidity which is measured in the KESF 2 system. KESF 2 system measures the bending rigidity and it is directly related with the Cauchy value. That means, if we get higher bending rigidity, so we will get higher Cauchy value. And if we see it is a 2 Hg. What is 2 Hg? It is a shearing hysteresis. Shearing hysteresis, it is a negatively correlated. What is this? This means higher shearing hysteresis gives lower Cauchy value. that means it is not the stiffness, it does not talk about the stiffness, it talk about the stiffer higher bending rigidity with a lower stiffness, that is the type of thing it is telling. So, 2 HB, so 2 HB is it is a bending hysteresis. So, bending rigidity is there positive way, but bending rigidity, bending hysteresis should be in the negative side, 12% contribution, but that means higher bending hysteresis will give us lower Cauchy value, okay. And WT it is a tensile energy. So, tensile energy also higher tensile energy will give us lower Cauchy value. So, this way this concept of Cauchy, it is not that straightforward, it is an overall concept. So, it is related with other parameters also, there are say these are the parameters, it is WT, it is a tensile energy, it is then bending energy, bending hysteresis, it is shear stiffness, shear hysteresis, compressional resilience, mean deviation of mu, MMD, and SMD, geometrical roughness. So, all these parameters are related here with this. Let us see the Sinai Akasha. What is this? It is a flexibility with soft filling. Flexibility with soft filling, if we see, it is a maximum contribution is a bending rigidity, maximum contribution of bending rigidity here, but it is a opposite. So, here it is talking about the flexibility, Cauchy was talking about the stiffness. So, minus B minus 44% means if we increase the B value we will get lower Sinai Akasha. So, it requires, that means soft lower B value will give us the higher Sinai Akasha, although the contribution is very high. So, it is directly correlated, it is inversely correlated with this, okay. And Sinai Akasha, it is a soft filling, flexibility with soft filling. What does it mean? It is see it is a MMD, it is a mean deviation of mu, it is a higher mean deviation of mu, it will give us lower value of Sinai Akasha. Its contribution is 10%. G shear stiffness, its higher stiffness will give us lower Sinai Akasha. 2HB, it is a basically it is a bending hysteresis. So, higher bending hysteresis will give us lower value. So, we can see this Sinai Akasha from this contribution value we can get idea about what does it mean. It is a total at once one feeling, one type of feeling, and Shari it is called crispness, it is crispness of the fabric, where G the shear stiffness it is related with that contribution is 32%, 1/3 contribution is of G value shear stiffness, but higher shear stiffness will give us lower Shari value, lower crispness. So, if we want to have crisp higher Shari, we need to have lower G value. So, it is another contribution which is positive in nature, it is MMD, mean deviation of mu, that means the deviation of mu at the different point it gives a crispness, that means somewhere it is a slipping sometime. So, we can see that this type of feeling in silk crispness, so crispy feeling. So, it slips, stick slipping type. So, mean deviation of mu it is a good indication of the Shari, and SMD its contribution is that 8%. What is SMD? It is a geometrical roughness. So, geometrical roughness is also, so if the geometrical roughness is high, it will give us the crispness little bit. So, maximum contribution is the shear stiffness. So, lower shear stiffness will give us higher Shari value, and that higher MMD will give us the higher Shari value. That means, if we see, if we take the, if we say eliminate SMD and RC, compression resilience, their contribution, if we talk about only these two major contribution, we can see that it is a fabric should shear easily, it should shear easily, but the difference in mu should be high, the MMD should be high. Okay. So, higher MMD with lower G value. So, this way we can get the concept of the that this contribution and their tactile sensation. Okay. Now, we will start the another set of instruments, which is fast instruments, and this fast instruments developed by CSIRO Australia. Okay. So, this is and it is primarily it is actually it is a quality control and quality assurance purpose, but indirectly we can use this for measuring the fabric tactile responses. So, it gives the indication of the fabric handle. The instruments are very simple, but the analysis of this from this data, it is very nice. Okay. So, we will see that with a very simple measurement we can get wide range of data, wide range of information. So, this total fast system, it consists of 3 test parameters, test instrument. Okay. 3 instruments are got. One is compression meter, it is a simple compression tester, and it is not like Kawabata system. KESF system gives total curve, it is a very complex, it is a very complex system. It gives the total loading direction and unloading direction, it takes the total data, but here in fast system it does not give any continuous measurement. In Kawabata both loading and unloading direction we get continuous data, continuous curve. Fast system we do not get any continuous curve, it is a discrete data, very discrete data, it is a 1 or 2 data it gives. From there only beauty of this system is we get we can analyze, if we analyze properly we will get large number very nice information. So, it has got fast has got 3 instruments. So, fast one is compression meter, fast 2 gives the it is bending meter, and fast 3 it is extension meter. Okay. So, here in all these 3 we do not get any curve, and this all these things all these 3 instrument it works in unidirectional, one direction, in only in the loading direction. We do not get in the anything, any information during the unloading direction. Okay. And fourth one is it is not an instrument, it is a test method. What is the test method? First 4 is the dimensional stability, okay, test which are inexpensive. It is a very this first 4 we do not need any instrument, we can actually develop one system of measurement, and these instruments are it is not that complex, these are robust in construction, and but this all these 3-4 modules can be interlinked. The computer its output can be interlinked, and ultimately we can get the information. Okay. Now, let us see first one, working principle of first one. It is a compression meter, it measures simply it measures the fabric thickness and nothing else, but let us see how do we get large information, okay, very nice information. Okay. The fabric thickness, it is a thickness gauge, it is nothing but a thickness gauge. So, fabric thickness T is measured at a pressure of 2 gram force per square meter and 100 gram force per square meter. This, that is all. At two different thickness pressure, we measure the fabric thickness, and from there we get the idea of surface hairiness, which is the term, it is a surface thickness. Surface thickness, it is a difference in fabric thickness at 2 gram force per centimeter square pressure and 100 gram force per centimeter square. So, within this 2 pressure, if the fabric thickness changes, then the difference is known as the surface thickness. That means, this surface thickness gives an idea about the surface hairiness. Suppose the fabric does not have any hair, a fabric made of say monofilament yarn, or yarn fabric is singed, there is no hairiness. So, the difference between 2 gram force per square centimeter, it is and even 100 gram force per square centimeter, it is a very low pressure. So, this in this two difference will be very low, but if the fabric surface contains large number of hairs, so that hairs will first get compressed at lower pressure. So, that the difference will be high, that actually is indicated by ST. So, only by measuring the thickness we get idea about the presence of surface hairs. So, we can get idea of the prickle sensation also from this ST value. This is surface thickness. So, it is the difference in thickness measured at two different pressure. Information on hairiness or surface bulk is obtained. So, it is a surface bulk we can obtain. A fabric may be soft at the surface and hard at the core. So, that way we can get idea about this by measuring the surface thickness. Another term we can get, it is called released surface thickness. Released surface thickness is it is nothing but surface thickness after the fabric has exposed on steam or water, which is used to simulate the actual wear condition. Now, released surface thickness is a parameter which will give us an idea about the presence of or permanence of a particular finish. Suppose we have given one calendering finish, and after one use, okay, after certain time, if we get, so if we get the calendering finish, so that means the surface is stiff. So, we get a certain surface thickness ST value before use. So, that value we get, but after say one laundering or after one wash, so this surface hairs has come up, that all these hairs have come up and the surface thickness value will change. So, that change that is after treatment, after washing treatment, if we measure the surface thickness, it will be released surface thickness. If there is wide difference between ST and STR, that means that the whatever finish has been applied, it is not permanent, it has been washed out. So, that STR and ST, the difference value, it gives an idea about the whether the finish applied is actually there, it is a permanent or it has been washed out. So, this gives an idea, and accordingly we will get the our tactile sensation. So, this is the surface thickness and release surface thickness as we have discussed, and try to see the principle. It is very simple. This is the support, here is the fabric, this is the fabric sample, and we know the fabric thickness, and this is the pressure foot, and this thickness gauge will give us an idea about the thickness. And now, at certain pressure as we have discussed. So, these are the pressure at 2 gram force per centimeter square and at 100 gram force per centimeter square. If we measure this thickness, so this is the thickness difference. So, this is the difference is surface roughness, surface thickness. Okay. Now, and if we wash the fabric, we may get higher surface thickness. That is called release surface thickness. So, from here we can get the idea about the thickness, idea about the hairs present at the surface, and also idea about the whatever finishes we have applied, the finish is actually working or not, whether the finish has been washed away, that information also we can get by released surface thickness. Now, the next module is it is a phase 2, which is bending meter. It is exactly similar as the Surley bending tester, and we get the similar characteristics here, bending length and bending rigidity, and the measuring principle is exactly same as the Surley bending tester, and fabric bending length, it simulates the draping period. So, from the bending length value we get the idea about the draping behavior, okay, and bending rigidity. So, this we can get, and which is actually indirectly give idea about the stiffness of the fabric. So, stiffness indirectly gives the idea about the tactile sensation. So, from BL value and the bending rigidity value, we get indirectly the idea of the tactile sensation of the fabric. So, a very flexible fabric with low bending rigidity may cause seam puckering. So, it actually, in addition to the tactile sensation, this information, this first instrument measures it gives the idea about the sewability of the fabric. So, a fabric with a very low bending rigidity may cause a seam puckering. So, while a fabric with high bending rigidity can be more manageable in sewing, so produce flat seam. So, that way we can get idea about the performance of the fabric during sewing operation, and the operator error in aligning the sample is eliminated with the use of optical sense. So, that operator error can be eliminated, because in this instrument the alignment of the sample is very important, and optical sensor is used for better alignment. So, this is the first system, it is exactly same as the Surley bending stiffness tester, and here is the bending length, and which 41.5 degree Celsius 5 degree angle it as soon as it measures, this free length is it is a bending length, okay. And first 3 is it is a extension meter. So, this instrument gives idea about the tensile as well as shear rigidity. So, this it gives idea about the extensibility, it is not the tensile, you can say it only gives the extensibility of the because at a fixed load dead weight, if we actually if it hangs, what is the extension, it gives the only that idea. It is not like Kawabata system where we actually load and unload, and as well as it gives the shear rigidity value. Now, it works in two different module. So, arrangement of fabric will be different for extensibility measurement and shear rigidity measurement. Okay. It is capable of measuring the fabric extensibility in both warp and wave direction and also bias direction. So, when it is working in bias direction, that time it gives the shear rigidity, and when it is working in warp and wave direction, it gives the extensibility of the fabric. So, extensibility is measured at 3 loads. One is 0.5 gram force per centimeter, it is called E5, then 20 gram force per centimeter, it is a E20, and 100 gram force per centimeter, it is a E100. So, this actual extensibility is we can get at from anywhere from 3A. E100 is the extensibility of the bending, but formability of the fabric, we can get idea from E5 and E20. So, at lower level of extension, lower load at extension at lower level of load, which gives the idea about the formability, we will discuss. So, fabric extensibility, when it is combined with bending rigidity to calculate the formability. So, which is a measure of ability of fabric to absorb compression, okay, on its own plane without buckling, that is called formability. So, that means with the lower level of extension and bending, if we know. So, fabric actually, if anything, any material, if we compress, if we buckle, if we compress, it will start buckling, but fabric actually takes little bit time. So, depending on the bending rigidity and the extensibility, it actually that some during sewing operation, during other various other operation, it has to absorb little bit compression, actually longitudinal compression, it is not lateral compression, no, longitudinal compression before it starts buckling. So, compress longitudinal compression on its own plane without buckling. Otherwise, if it starts buckling from the beginning, then it may create problem in the during sewing operation. So, formability is calculated from the difference between E5 and E20. So, these two parameters are used, and E100 is a measure of extensibility. But these 3 parameters we get from extension meter. So, simply we have to hang a constant weight and we have to note down the data extension, but the instrument automatically note down the data from its software, and it gets the data and it calculates the formability value from the and in combination with the bending rigidity value. If the value is below approximately 2%, that means with this E100, then fabric will be difficult to extend during seam overfit. So, that extensibility we can get idea. This is the simple measurement technique. So, this before loading we know the distance length, and after loading you may be 5, maybe 20, maybe 100, we get the extension, and automatically the software records the data, okay, and from there we can calculate. Next is the shear measurement by same instrument, first 3. In the extension measurement we have seen here the thread direction, if we see the woven fabric, it is a warp, either warp or wave direction, this is either warp or wave direction, but in the shear measurement, when we measure the shear rigidity, the it is not aligned in the either warp or wave direction, it is aligned in the biased direction, and the extension it is called biased extension, and this biased extension at a certain load is converted in terms of shear rigidity. So, this is the type of arrangement. So, before loading this is the fabric arrangement, and after loading and this is the extension. So, lower shear force will give higher extension. So, from there simply by changing the fabric orientation we can get the idea about the shearing. It is nothing, shearing is nothing but the movement of here movement of yarns in its interlacement zone. Okay. So, shear rigidity below 30 Newton per meter, fabric deforms easily. So, that way, and it gives different types of problem, laying up and sewing problem, and if it is above 80 Newton per meter it is very stiff, it is difficult during sewing operation, and there are different, even it will give idea about the tactile sensation. And next one is it is a system which measures the relaxation shrinkage RS and hygral expansion, it is HE. What is hygral expansion? It is after when we fabric is in wet condition and after drying, what is the change in length dimension, from there we can get the hygral expansion and relaxation shrinkage. Relaxation shrinkage means it is after washing and all this, after relaxing, if you dry, what is the actual dimension, what is the shrinkage. So, relaxation shrinkage is mainly due to the recovery of fabric structure which got strained during manufacturing. So, at a certain it is get after manufacturing it is strained, after that it is relaxed, and very high relaxation shrinkage results in problem of changing the size of the garment. So, it gives the different types of tactile sensation. If the fabric it is highly relaxed, then it will give pressure higher pressure sensation. So, this is a test method for measuring the relaxation shrinkage and hygral expansion, and hygral expansion or contraction. So, it may be of two types. So, depending on the fabric is caused by swelling or deswelling of hygroscopic fiber. So, basically the shrinkage is it takes place when we during washing, it is due to the swelling characters as we know. So, hygral expansion, higher hygral expansion may result in seam puckering, fabric waviness, buckling and overall poor garment appearance. Okay. So, that will. So, the testing is completed in following 3 steps. Okay. So, we have to have 3 steps. In step 1, fabric specimen is oven dried. First we have to oven dry the specimen up to 0% moisture regain to measure the dry dimension. So, dry dimension is say L1 is the dry dimension, then it is soaked in a water, and the wet relaxed dimension is L2, and the fabric is then dried to measure its the final dry dimension, it is S3 L3. So, L1, L2, L3 are the 3 dimensions, and from there we can get the relaxation shrinkage is L1 minus L3 by L1. This is the relaxation shrinkage, and hygral expansion is L2 minus L3 by L3. This is the hygral expansion. We can get the idea about it. Now, try to see the total the steps. In step 1, this is the fabric, we are actually first oven drying the fabric. First we are oven drying the fabric and getting the dimension L1, length or breadth, whatever dimension we want, warp wise or weft wise, this is L1. Then we are soaking the fabric, this is the fabric we are soaking. So, ultimately we are getting the length L2, and after that we are re-drying again, this is the L3. So, this difference, this is due to the hygral expansion, this is due to the this increase in this length, higher length as compared to L3, L2 is as compared to L3 is due to presence of water, because already the fabric has been relaxed here. So, that this difference is its with the reference to L3 is known as the hygral expansion, and relaxation shrinkage is from this to this. Once we are soaking and drying, this total, this gives the idea about the laundering effect. So, when we launder the fabric, wash the fabric, we first soak with water and then dry. So, this gives RS gives the relaxation shrinkage. So, depending on this value, we can get idea about the performance of the fabric. So, the how to interpret this data, which is very important in FAST. FAST system, it is a very simple, but interpretation is very nice. So, here all the modules are connected with the computer, and computer automatically gets data from all the modules, and even including the FAST 4 module, we have to feed the data of the relaxation shrinkage or hygral expansion, and finally with this data it plots a curve which is known as the FAST control chart or FAST fingerprint, and this is the chart for a particular fabric. For a fabric, it gives a separate chart, and from this chart one can immediately get the idea about the fabric, what will be its performance during application. So, which is unique to each particular fabric. For a particular fabric, it is unique. Each value has a separate scale showing in the graph. I will show you the graph. Okay. Separate scale, separate parameter, they have got separate scale representing the range of value in appropriate units. It gives from say warp and weft direction. So, it gives the range of the values, and the total value minimum and maximum value it will give, and also that the FAST chart is a fixed chart. Okay. So, it gives the range from minimum to maximum value, and also it is a shaded zone is there. Shaded zone means it is a problematic zone. Within that zone, if the fabric gives the value, that means we can anticipate some problem in application. If the fingerprint falls into one of these zones, okay, that is the shaded zone, okay, a potential problem with the particular aspect of fabric performance which is indicated. Okay. So, now let us see typical FAST control chart. This is the empty FAST control chart. Now, here we can see these are the graphs, this is the blank, okay, chart. It is a lower value, it is a higher value. Let us say relaxation shrinkage RS1 and RS2. What does it mean? RS1 means it is a warp direction, RS2 say it is a weft direction. Okay. Hygral expansion, it is HE1, HE2. See, RS1 relaxation shrinkage, if it is very low, what will happen? The problem may be fusing or pleating problem. So, that problem it may create. If it is high, that is sizing problem. At size, if it is relaxed shrinkage is high, that means size may get changed. So, that type of problem will be there. Hygral expansion, if it is low, there will not be any problem, it is good. If it is high, there will be pleating or shimp occurring. So, that type of, so if our data falls in this zone, so that means we can anticipate some potential problem of this fabric. So, we have to take action. Okay. Formability, if it is high, it is perfect, okay, formability, but if it is low, then formability problem will be there. Extensibility, so formability F1, F2, warp direction, wave direction. Extensibility E101, it is a, if it is low, then there will be overfitting, overfit molding problem, and if it is very high, say if it is extends problem, then there is a problem of check matching layup, means during automatic cutting in garment industry, the check matching will be problem, because large number of layers are laid automatically, and if the fabric is extensible, that means the check matching, if it is checked fabric, then there will be a problem. Okay. Then bending rigidity, so if it is high, there will be cutting problem, and shear rigidity, laying up problem, thickness, surface thickness, okay, release surface thickness. So, this all these characteristics we, so this thickness, surface thickness, release surface thickness, this there is no warp and weft. So, that is why it is a single line, and this is a typical control chart. Now, what does it show? This fabric is tested in fast testing, fast instrument, and we get this control chart. That means, this fabric will have problem in sizing due to very high relaxation shrinkage of warp direction. So, problem will be in the warp direction, wave direction we do not have any problem. So, we have to take action, or whatever precaution we have to take, we have to do. Okay. And say hygral expansion, it is a perfect, warp wise and weft wise hygral expansion is exactly same. Here warp wise and weft wise wide difference. Similarly, we can see this fabric will have problem with the say check matching problem, at least in warp direction. So, it has got lower bending rigidity, it has problem with this. So, this will give idea of potential problem which is going to have. So, we can take precaution. So, this is one fabric which pass the fast test. So, this fabric you can very well use for any application, okay. But for other fabrics, if there is any problem, we can take either precaution or we can some corrective measure we can always take, okay. And we will stop here. Next we will start other principle, which is fabric extraction principle, okay. Thank you.